Simple as possible or SAP-1 is a bus organized computer. All registers are connected to the W bus. The SAP-1 architecture. The SAP-1 has been designed for beginners. The main purpose of SAP-1 is to introduce all the crucial ideas behind computer operation without burying you in unnecessary detail. SAP-1 is the first stage in the evolution toward modern computers. SAP-1 is a big step for beginners. And now, let's continue. Program counter. Generated by 4-bit program counter that counts from 0000 to 1111, total of 16 memory locations. Input and memory address register or march. The march stores 4-bit address of data and instruction which are placed in memory. When SAP-1 is running mode, the 4-bit address is generated by the PC which is then stored into the march through W bus. A bit later, the march applies this 4-bit address to the RAM, where data or instruction is read from RAM. There are 16 memory locations and each location contains an 8-bit of data. Instruction register. Fetch instructions from the RAM. The contents of the instruction register are split into 2 nibbles. The upper nibble is a 2-state output that goes directly to the block labeled controller sequencer. The lower nibble is a 3-state output that is read onto the W bus when needed. Adder subtractor. SAP-1 uses fuse complement adder subtractor. Accumulator. To add or sub 2 8-bit numbers A and B, the accumulator register stored the number A. It stores the output of adder subtractor. B register. To add or sub 2 8-bit numbers A and B, the B register stored the number B. It supplies the number to be added or subtracted from the contents of accumulator to the adder subtractor. Output register. At the end of an arithmetic operation, the accumulator contains the word representing the answer. Then answer stored in the accumulator register is then loaded into the output register through W bus. Binary display. The binary display is a row of 8 LEDs. Therefore, after we've transferred an answer from the accumulator to the output port, we can see the answer in binary form. Controller sequencer. The 12 bits coming out of the CS form a word that controls the rest of the computer. The 12 wires carrying the control word are called control bus. The CS sends out control words on during each T state. These words are like directions telling the rest of the computer what to do. The SAP-1 opcode. Fetch cycle. The control unit is the key to a computer's automatic operation. The control unit generates the control words that fetch and execute each instruction. While each instruction is fetched and executed, the computer passes through different timing states, T states, time intervals during which register contents change. Ring counter has an output of T equal T6, T5, T4, T3, T2, T1. Each ring word represents 1 T state. The ring counter produces 6 T states. Each instruction is fetched and executed during these 6 T states. The T1 state is called the address state because the address in the program counter is transferred to the march during this state. The T2 state is called the increment state because the program counter is increment. The T3 state is called the memory state because the addressed RAM instruction is transferred from the memory to the instruction register. The address, increment and memory states are called the fetch cycle of SAP-1. Execution cycle. The next three states, T4, T5, and T6, are the execution cycle of SAP-1. The register transfers during the execution cycle depend on the particular instruction being executed. Here's a sample instruction set. So please listen and watch it carefully. When executing the LDA instruction, a passageway from the IR to March is used to transfer the address from March. The instruction which is burdened from RAM and store intermediate result of computer operation which has two outputs. This two-state output which goes directly to the adder subtractor and the three-state output which goes to the W bus. In executing add instruction, the content of the accumulator will be added to the content of the memory in the address, placing the sum back to the accumulator. A buffer register used to hold one operand of the arithmetic operation while further is kept back by the accumulator register. In out execution, after the fetch cycle the contents of the RAM was loaded to accumulator. A control signal is activated when it has to be displayed. In HLT execution, it tells the computer to stop the processing data. At the end of computer run, the accumulator contains the result of operation and it's stored in output register. Thanks for watching. So please subscribe, comment and rate. We hope you enjoyed and learned from our video presentation. Good luck and have a nice day.